Hello students and good afternoon. So now I am doing class for class 12 science. The topic is the same topic that we were doing in the last online class, that is integration by parts. So today is the continuation class of this chapter, integration by parts. Same exercise 7 4 mark section from page number 380 from the book Higher Mathematics for class 12 by SN Day. So let's do this question number 35. So you have to evaluate this integration, that is integral of tan inverse root over x dx. So let us do this integration. So therefore I is equal to integration of tan inverse root over x dx. So let us evaluate this integration. So this is the only inverse circular function here. If there is only inverse circular function, then also you have to do integration by parts. Actually there are two functions here. One is tan inverse root over x, that is inverse circular function, and the other one is one, that is x to the power 0, that is your algebraic function. So there are two functions here. One is inverse circular function and the other one is algebraic function. One is I and the other one is E. So which letter comes first in the word let or islet? I comes first, that is inverse circular function is the first function out here. That is tan inverse root over x is the first function and 1 is the second function. So let us use integration by parts. So therefore I is equal to, this is taken outside, tan inverse root over x integral sign dx minus integration of second bracket, this is dy dx of tan inverse root over x, right? Then integral sign dx second bracket closed dx. So I think you have understood it. So or I is equal to, let us integrate first. What is integral sign dx? X, then it is tan inverse root x minus integration of, what is dy dx of tan inverse root over x? You know the differentiation of tan inverse x, isn't it, with respect to x? That is, what is the differentiation of tan inverse x? It is 1 upon 1 plus x square. But here it is 1 upon 1 plus, what is x square here? Root over x whole square into, again differentiate the term which is assumed as x. In this case, root over x is assumed as x. So what is the differentiation of root over x? It is 1 by 2 root x. It is 1 by 2 root x into, what is integral sign dx? That is your x. Then what do we write? dx. Is that clear? So here you can cancel root over x, ones are root over x, root over x. So x is cancelled by root over x and it goes root over x times. Or I is equal to x tan inverse root x minus integration of, so here half is taken outside because it is a constant quantity. Integration of, this is root over x dx divided by, this is your 1 plus x, because root over x whole square is always x. So we can take this integration as I1. So I is equal to x tan inverse root over x minus, let us write it as I1. Okay. So let us evaluate this integration which is assumed as I1. So let us write I1 now. Let I1 is equal to half integration of root over x dx divided by 1 plus x. Okay. So how will you evaluate this integration now? So we have done it in the previous chapter, that is in method of substitution we have done it, and in standard integral also we have done such type of integration. Okay. So what is the method for integrating it? So let us remove square root from the denominator, that is root over x. So let us put x is equal to z square. That is the method of substitution. So here we put let x is equal to z square. So differentiating both the sides with respect to x. Therefore dy dx of x is equal to dy dx of z square. We are differentiating both the sides with respect to x. So what is dy dx of x? That is your 1 is equal to, what is dy dx of z square? 2z into dz by dx. Okay, so let us do cross multiplication. What is dx is equal to? This is your 2z dz. So we have got the value for dx, which is equal to 2z dz. Now what is I1? So this is I1 is equal to half integration of within square root. What is x? It is z square into, what is dx? It is 2z dz divided by 1 plus z square. 1 plus z square. So here 2 gets cancels. Okay. So or I1 is equal to integration of, what is square root of z square? Your 2 gets cancels. What is square root of z square? That is your z. So z into z is z square divided by 1 plus z square. Then what do we write? dz. So I think you have understood it. Okay. So now in this particular function, the highest power of z in the numerator is 2, and the highest power of z in the denominator is also 2. That is, the highest power of z in both the numerator and the denominators are same. So what is the method here? Whatever is there in the denominator, you write it in the numerator. Okay, that means we will write 1 plus z square in the numerator here. So therefore I1 is equal to integral sign. Let us write 1 plus z square in the numerator. So let us keep it within bracket, 1 plus z square, right? So z square is there, but is there 1 in the numerator? No, you have to cancel it. So you should write minus 1 divided by 1 plus z square. Then what do we write? dz. So now let us separate the term here. So or I1 is equal, let us separate the term. This is integral sign, 1 plus z square upon 1 plus z square is 1. That is your dz, minus integration of, this is dz divided by 1 plus z square. Okay. Now you can easily integrate dz. And this is integration of dz divided by 1 plus z square. This is your first standard form from method of substitution. So this one can be written as 1 square. Okay. So this is in the form dz divided by x square plus a square. That is the first standard form. So what is the formula for the first standard form? It is 1 upon a tan inverse x upon a. So here let us write, or I1 is equal to, this is integral sign dz is z minus, this is the first standard form, this is dx upon x square plus a square. Instead of a there is 1, instead of x there is z. So what is the formula? 1 upon a tan inverse x upon a. So here 1 upon a is 1 upon 1, tan inverse, what is x upon a? Z upon 1 plus c. Is that clear? So let us put the value for z now. So I1 is equal to, what is z? Since z square is equal to x. So what is the value for z? It is root x minus, you don't have to write 1 upon 1, that is 1. Okay. So tan inverse within bracket, what is z? Z is root x. Z is root over x plus c. So that is the value for I1. Okay. So let us put this value of I1 in I. So we have I is equal to x tan inverse root over x minus I1. So here we can put the value for I1 in order to get the value for I. So therefore I is equal to, what is the first term here? X tan inverse root x x tan inverse root x. Then we have minus I1. Let us put the value for I1 now. So because of this minus sign will be changed. So minus root over x, minus into minus plus, it is tan inverse root over x. Now this is minus into plus is minus c, but since this is a constant c only, you have to write either minus c or you may write plus c also. So we can write plus c here. So this is the final answer. Okay, so this question is also very, very important. You can mark it, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 36. That is, you have to evaluate this integration. That is integral of x sin 2x dx. So how can you evaluate this integration? Okay, so now there is sin x sin 2x is there. This is in the form sin a sin b. Greater angle is taken as a and the smaller angle is taken as b. So it is sin a sin b. In this case, we can use the formula from transformation of products and sums in trigonometry. So you should know this formula. That is 2 sin a sin b is equal to, what is the formula? What is 2 sin a sin b is equal to? That is cos of a minus b minus cos of a plus b. You should know this formula. This is from transformation of products and sums from trigonometry. 2 sin a sin b is equal to cos of a minus b minus cos of a plus b. Okay. So we need 2 out here. For this sin x sin 2x we need 2 there. Okay. So let us write I also. I is equal to this is your half integration of x within bracket 2 sin 2x then sin x bracket closed dx. Is that clear? Now this is 2 sin a sin b. 2 sin a sin b, or I is equal to half integration of x. Now within bracket, what is this 2 sin a sin b? 2 sin a sin b here is cos of a minus b, isn't it? So it is cos of, what is a minus b? 2x minus x is x, minus cos of, what is a plus b? 2x plus x is 3x, bracket closed dx. Is that clear? So we are using the formula of 2 sin a sin b, which is equal to cos of a minus b minus cos of a plus b. So in this case we have cos of 2x minus x is x, minus cos of a plus b is 2x plus x is cos 3x. Okay. Now we can multiply these two expressions and we can separate integral sign and dx also. Okay. Or I is equal to, this is your half integration of, this is x cos x dx, right? Then minus sign is there. Again it is half integral sin x cos 3x dx. Okay. Now for both this integration, you have to use integration by parts. So one of the function is algebraic function and the other function is trigonometric function. So a and t are there. A and t function are there. Algebraic a and trigonometric t functions are there. So a comes first in the word liet or islet. So here x is the first function and cos x or cos 3x is the second function. Okay. So let us use integration by parts here. Or I is equal to, this is your half within third bracket. Here x is the first function, x is taken outside, integral sin cos x dx minus integration of second bracket, this is d by dx of x, then integration of cos x dx second bracket close dx. then also third bracket is closed. So this is integration by parts for this first function. Okay, so this is the continuation line here. Let us write here minus half within third bracket. Again, you can use integration by parts in this case. Here x is the first function, that is algebraic function, and cos 3x is the second function, that is your trigonometric function. So let us use integration by parts. So it is x integration of cos 3x dx minus integration of second bracket dy dx of x integration of cos 3x dx second bracket is closed dx. So this is integration by parts. Here also third bracket is closed. So I think you have understood it. So let us evaluate this integration now. So let us write here, or I is equal to half within third bracket x into what is integration of cos x dx? It is sin x. It is sin x minus integration of what is dy dx of x? That is your 1. You don't have to write it. What is integration of cos x dx? That is your sin x. Then you can write dx. Third bracket is closed. Okay. Then minus sign. Minus half within third bracket. X is kept as it is. So what is integration of cos 3x? Sin 3x divided by 3. So it is sin 3x divided by 3. Then minus sign is there, integral sign. What is dy dx of x? That is your 1. And what is integration of cos 3x? Sin 3x by 3. So it is sin 3x upon 3. Is that clear? Then you should write dx. Third bracket is closed. So now let us open this bracket. Or I is equal to half x sin x, then minus half integration of, this is your sin x dx, right? Now let us multiply by minus half here also. So minus 1 upon 6 x sin 3x, and this is minus into minus plus 1 upon 6, right? And this is integration of sin 3x dx. Is that clear? So now we can evaluate these two integration. Or I is equal to half x sin x minus half into, what is integration of sin x? It is minus cos x, you know that. Minus cos x minus 1 upon 6x sin 3x plus 1 upon 6 multiply by, what is integration of sin 3x? It is minus cos mx by m, that is minus cos 3x by 3. Then what do we write? Plus c. Or I is equal to, this is x by 2 sin x minus into minus plus half cos x, right? Then minus x by 6 sin 3x. Is that clear? Then plus or minus, this is cos 3x divided by 6 3s are 18 plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now let's do this question number 37. So these two questions are of similar type. We will do question number 37 here, that is integration of x tan x sec square x dx. Okay, we'll do it here 37, and this asterisk marks, this problem is your homework. This is not from the book. right? So you can evaluate this integral sine x cot x cosec square x dx. So these two questions are of similar type. Let's do question number 37 here, and this is your homework. Is that clear? So let's do this question number 37. So let us write first I is equal to integration of x tan x, then sec square x dx. So both the problems are very important. Okay, so here x is an, directly we can use integration by parts here. Here x is the algebraic function, that is a, tan x sec square x is the trigonometric function, that is t. So among these two letters a and t, which letter comes first in the word let or islet? A comes first, isn't it? So here a means x is the algebraic function, so x is the first function and tan x sec square x is the second function. Is that clear? So let us use integration by parts. So x is taken outside, this is the first function, integration of tan x sec square x dx. Then comes minus sign, integration of second bracket dy dx of x. Okay, then integration of, this is your tan x sec square x dx, second bracket close dx. Is that clear? Now in this case there is integration of tan x sec square x dx, there is also integration of tan x sec square x dx. You cannot evaluate it directly here. So let us take it outside. Let us find out the integration of tan x sec square x dx. Both the functions are here, isn't it? So let us take it outside and let us write it as I1. That is, let I1 is equal to integral sine tan x sec square x dx. So let us evaluate this integration. Okay, so how can you evaluate this integration? Here you can do the method of substitution, because the differentiation of tan x is sec square x, so we can assume tan x as z. So let z is equal to tan x. So differentiating both the sides, with respect to x. So it is dz by dx is equal to, what is the differentiation of tan x? It is sec square x. Let us do cross multiplication. Dz is equal to, this is your sec square x dx. So we have got the value for sec square dx, which is equal to dz. Okay, so let us put them in I1. So therefore this is I1 is equal to integration of tan x, here is z, into what is sec square x dx? It is dz. Okay, so what is I1 now? So therefore I1 is equal to, what is I1 here? It is, what is integration of z dz? It is z square by 2 plus c. It is z square by 2 plus c. Or I1 is equal to, what is z square? That is z square, here is, what is z square? Since z is tan x, what is z square? It is tan square x. So this is your tan square x by 2 plus c. So that is the value for I1. Okay, so what is the integration of tan x sec square x dx? It is tan square x by 2 plus c. So again you have to put these values of I1 in I, but don't write c here. Don't write c here, otherwise you will get confused. Okay, so now what is I is equal to? So I is equal to, now here it is x, right? So what is integration of tan x sec square x dx? It is tan square x by 2 plus c, but don't write c out here. You write only tan square x divided by 2. So in the previous problem also we integrated it directly and we write down only the integration of this function, but we don't write c out there. So here also don't write c in this case. Okay, so minus, so it is minus integration of, what is d by dx of x? That is your 1, you don't have to write it. And what is integration of tan x sec square x dx? It is tan square x divided by 2. d by dx of x is 1, you don't have to write it. What is integration of tan x sec square x dx? It is tan square x by 2. We just got the integration of tan x sec square x dx, isn't it? So what is the integration of tan x sec square x dx? It is tan square x by 2. Then we write dx. Okay, so or I is equal to, this is x tan square x divided by 2 minus half is constant taken outside, integration of, this is your tan square x dx. Okay, so what is integration of tan square x dx? Can you get its integration directly? No, there is no integration for tan square x, but we have got the integration of sec square x, isn't it? So you know that sec square x is equal to 1 plus tan square x. You know this relation, isn't it? Or now sec square x minus 1 is equal to what? It is tan square x. So what is the formula for tan square x in terms of sec square x? It is sec square x minus 1. So instead of tan square x, you have to write sec square x minus 1. Or now this is I is equal to x tan square x upon 2 minus half integration of, this is your sec square x minus 1 bracket closed dx. Okay, so now you can separate this integral and then you can integrate it. Or I is equal to x, this is tan square x upon 2 minus half integration of, this is your sec square x dx. Okay, minus and minus plus, this is half integration of dx. Understood? So now let us evaluate this integration again. Or I is equal to x tan square x by 2, okay, minus half into, what is integration of sec square x dx? That is differentiation of which function is sec square x? This is your tan x, right? So half into, what is integral sine dx? That is your x. Half into, what is integral sine dx? That is your x. Then what do we write? Plus c. So this is the final answer. So this question number 37 is very important problem. You can revise it at home. So you can copy it. So this question, that is asterisk mark, this question is your homework. This is also very important. Okay, this question is also very important. So this is your homework. Now let's do the next question now. So now we'll do the next question, that is question number 38. You have to evaluate this integration, that is sine inverse x divided by x square dx. So let us write first I is equal to integral sine. Also you can take this x square to the numerator, so it becomes x to the power minus 2 and it is sine inverse x dx. Okay. So now here also there is integration of the product of two different functions. So here also you should do integration by parts. So now x to the power minus 2 is the algebraic function, that is a, and sine inverse x, this is the inverse circular function, that is I. So there are two letters here. One is a and the other one is I. So among these two letters a and I, which letter comes first in the word let or islet? I, that is inverse circular function, that is I comes first in the word let or islet. So this sine inverse x is the first function and this algebraic function x to the power minus 2 is the second function. Okay, so let us use integration by parts here. So I is equal to, this is sine inverse x integration of x to the power minus 2 dx minus integration of second bracket dy dx of sine inverse x integration of x to the power minus 2 dx second bracket closed dx. So this is the rule of integration by parts. Okay, or I is equal to, let us first integrate. Okay, so integration of x to the power minus 2 dx. This is in the form x to the power n dx. What is this integration? X to the power n plus 1 divided by n plus 1. So it is x to the power minus 1 divided by minus 1. That is x to the power minus 2 plus 1 divided by minus 2 plus 1. That is x to the power minus 1 divided by minus 1 into sine inverse x. Into sine inverse x. Minus integration of what is d by dx of sine inverse x. So what is this differentiation? 1 upon root over 1 minus x square. Okay, into, now again you have to integrate x to the power minus 2, that is x to the power minus 1 divided by minus 1. Then what do we write? Dx. Okay, so or I is equal to, this minus sign is written here outside. X to the power minus 1 means 1 upon x, and this is your sine inverse x, minus, so this minus into minus is plus, integration of, this is 1 into dx is dx, so this x to the power minus 1 is written in the denominator, it becomes x, isn't it? So x, this is root over 1 minus x square. Okay, so now we have to evaluate this integration. Let us write it as I1. So I is equal to minus 1 upon x sine inverse x plus, this is your I1. Okay, so let us evaluate this integration. Let I1 is equal to, let I1 is equal to integration of, this is dx divided by x root over 1 minus x square. Right? So in this case, you have to evaluate integration of dx divided by x root under 1 minus x square. So in this case also you have to use method of substitution. We have already done this type of problem in the previous chapters. Okay? So always you have to consider the expression under square root. So within square root there is 1 minus x square. So I already told you that whenever the expression is under square root and the expression is 1 minus x square, you always put x is equal to sine theta. So let us do the trigonometric substitution out here. Let x is equal to sine theta. Okay, so differentiating both the sides, with respect to theta. So therefore dx by d theta is equal to, this is your cos theta, isn't it? What is the differentiation of sine theta? It is cos theta. Now let's do cross multiplication. Dx is equal to, this is your cos theta d theta. Right? So therefore what is I1 now? So it is I1 is equal to integration of what is dx? It is cos theta d theta divided by what is x? X is sine theta into, within square root, it is 1 minus sine square theta. So let us simplify it again. Or this is I1 is equal to integration of cos theta d theta, right, divided by sine theta into, what is square root of 1 minus sine square theta? This is your cos theta. Your cos theta gets cancels. So or I1 is equal to integration of, what is 1 by sine theta? This is your cosec theta. This is your cosec theta d theta. So we have got integration of cosec theta d theta. So now you should know this formula. So what is the formula for integration of cosec theta d theta? This is log of cosec theta plus cot theta. So let us write here I1 is equal to log within mod. Log within mod. So what is integration of cosec theta d theta? It is log within mod cosec theta plus cot theta. Cosec theta minus cot theta. It is cosec theta minus cot theta. Okay, so what is integration of cosec theta? It is log within mod cosec theta minus cot theta, and the base is e and this is plus c. So I think you have understood it. Okay, Now since here the value for sine theta is x, so you have to express this cosec theta and sin cot theta in terms of x, right? So now what will you do in the next step? Let us write it in terms of sine theta, or I1 is equal to, this is your log base e within mod, not integration, within mod, because we have already integrated it. That is integration of cosec theta d theta. What is the formula? Log within mod cosec theta minus cot theta. Mod sign close, the base is e plus c. Okay. So now log base e within mod. So cosec theta can be written in terms of sine theta. So this is 1 upon sine theta minus, what is cot theta? It is cos theta divided by sine theta. Mod sign closed plus c, or I1 is equal to, this is log base e within mod. What's the LCM? It is sine theta. In the numerator we have 1 minus cos theta, mod sign closed, plus c. Okay, so now we have sine theta is equal to x. So let us change this cos theta into sine theta, or I1 is equal to log, here the base is e, within mod 1 minus, what is cos theta in terms of sine? What is cos theta in terms of sine? It is root over 1 minus sine square theta. This is divided by sine theta, mod sign closed, plus c. So let us put the value for sine theta in this case. So what is the value for sine theta in this case? It is x. So, or I1 is equal to log, here the base is e, within mod 1 minus root over 1 minus x squared divided by x, mod sign closed, plus c. Okay, but this is the value for only I1, but we have to get the value for I. So let us put these values in I. Let us put this value for I1 in I. So what do we get? So I is equal to minus 1 upon x, then it is sine inverse x, right? So this is the first function, minus 1 upon x sine inverse x, plus, let us write down the value for I1. This is plus I1. So it is plus log basis e within mod 1 minus root over 1 minus x squared, this whole divided by x, mod sign closed, plus c. So this is the final answer. So I think you have understood it, so you can copy it. Now we'll do the next question. So now we'll do the next question. That is, this question is from Higher Secondary 2015. So let's do this question now. The question is, you have to evaluate this integration. That is integral of sine root over x dx. So you cannot integrate it directly. You cannot take this function as sine x and then integrate. Okay, but there is sine root over x dx is there. So in this case, from this root over x, you have to remove square root from x. So how can you remove square root from x? You have to do the method of substitution. That means you have to put x is equal to z square. Okay. So let us first write I is equal to integration of, this is sine root over x dx. Okay. So I already told you that this function cannot be integrated directly because there is sine root over x dx is there. Okay. So in this case, you have to remove square root from x. That means you have to do the method of substitution in this case. So what should you put for x so that you can remove square root? You have to put x is equal to z square so that square root will be removed. So let x is equal to z square. So now let us differentiate it. Differentiating both the sides with respect to z. Okay. So dx by dz is equal to, this is 2z, z square differentiation is 2z, or what is the value for dx? It is 2z dz. Okay, it is cross multiplied. So let us put these values in I. So therefore I is equal to integration of, there is sine, what is root over x? It is root over z square, which is z, into what is dx here? It is 2z dz. Understood? So now in the next step, what will you do? Here 2 is constant, it is taken outside. I is equal to 2 is constant, it is taken outside. Integration of, let us first write z. Let us first write this z and then sine z. It is sine z dz. Now this is the integration of the product of two different functions. So you have to use integration by parts. Here z is there, z is an algebraic function, that is a, and sine z is a trigonometric function, that is t. So among these two letters a and t, which letter comes first in the word let or ilet? That is algebraic function, that is the letter a comes first in the word let or ilet. That means this algebraic function z is the first function, and sine z, that is trigonometric function, is the second function. Is that clear? So let us do this integration by parts. So therefore I is equal to 2 is constant. So within third bracket you have to use integration by parts. Here z is the first function, that is taken outside. That is z integration of sine z dz minus integration of second bracket dy dz of z integration of, then this is sine z dz, second bracket closed dz, then third bracket is closed. So we have integrated by parts. Okay, so let us simplify the expression within third bracket. I is equal to 2, within third bracket z is kept as it is. Now what is integration of sine z dz? That is differentiation of which function is sine z. So it is minus cos z, right? It is minus cos z minus integration of what is dy dz of z, that is your 1. Actually you don't have to write it 1. Okay, so what is integration of sine z? You know that this is minus cos z bracket closed, then you have to write down dz. Here third bracket is closed. Is that understood? So now you can multiply both these expressions by 2. So let us open the bracket now. So or I is equal to, this is minus 2z cos z, and minus into minus, this is plus, 2 is there, 2 integral sine, this is cos z dz. Is that clear? Or I is equal to minus 2z cos z plus 2 into, what is integration of cos z dz? That is differentiation of which function is cos z, that is your sine z, then plus c. But this is not the answer. You cannot write down the answer in terms of z, but you have to write down answers in terms of x. Again you have to put the value for z. Actually what was x? X is equal to z square. So what is the value for z from here? If z square is equal to x, what is z? Z is root x, right? So or I is equal to minus 2, z is root over x, isn't it? If z square is equal to x, so z is equal to root x, then it is cos root x plus 2 sine root over x plus c. So this is the final answer. Okay, so I think you have understood it, so you can copy it. This question is very, very important, and this question is from HS 2015. Okay, so this much is for today. So today also we did 4 or 5 problems. So you revise all the problems that we did today, and also you can revise all the problems that is included in this integration by parts. And in the next online class, we will do more problems on this integration by parts. So this much is for today.